Recording started. Okay, so I know Guy wasn't here uh early enough during lecture, but hopefully a lot of this makes sense like as we go over it. So all of this is just basically reading input, so we'll start from here. So we have to have a distance array with a number of nodes, and then we'll pre-initialize everything to infinity except our starting point, because like where we start, like we're already there, so its distance is 0. So we have a priority queue, and we have to get it started by pushing distance 0 at our start. So now we loop until our priority queue is empty. Um, we have to extract the distance to here from the top of the priority queue and what node we're currently at. And then once we're done with that, we just get rid of it. So I pop it off. And then as I mentioned, like on the whiteboard, it's possible for pairs in the priority queue to become outdated, right? Let's say like you have like you made some pair that you pushed into the priority queue, but you went another way and found a shorter distance than like what this current pair says you're at, right? So in that case, this pair is now useless because like you've already found a better way to get here. It can't possibly make anything better. So you just continue. Like you don't process the rest of this, so you just skip it. Um, and now that we're here, we know that okay, this node is better than like the best distance we have to get to this current node, so it can update other distances. So I'm gonna loop through all of the edges in this node's adjacency list. The reason I taught for each loops early was mainly so that you'd be comfortable with this, because if I were to write this as a traditional for loop, it would be terrible. But hopefully the names make it clear enough where this is looping through every edge in this node's adjacency list. So if I pull up paint, what happens is like let's say we have a node 1 and then like a bunch of like other like nodes, right? If we're processing node 1, I need to check every single edge that 1 connects to, right? Every single one of these 3. So that's what that for each loop is doing, right? So it's getting every pair in this node's adjacency list. So to make things a little more clear, I just made 2 more variables. So the destination that we're trying to get to is the first number in the pair, and the cost is the second number in the pair. So now if the distance to that it took to get to where we are plus the cost of this edge is less than the distance to this destination, then we update the destination and push it back into the priority queue. So update the destination distance and then push this into the priority queue. And then once we're all done with this, it should work, and then output your distance. And that's it. It's actually that simple. But uh, hopefully this seemed to tie in with the lecture a bit. Mainly like the part where I said like it's possible for things to be outdated, so you just ignore them if it's worse than what you've already stored. And then this part is just checking every edge that we're connected to, and then updating it if using this edge is faster than what we have stored. Does that make sense, Omar? Guy?
Say yes. So
Okay.
distance here plus cost, but I mean, since we initialize it, the distance to infinity, of course, it's
Mhm.
gonna be true for the first, like for the
Yeah,
first
for the first
iteration.
ones. Yep.
Yeah, and
Add
then we
something
will
like,
assign like
sorry.
a value for each destination, and then we are gonna loop again and try from each single destination. It's very similar to recursion, but but it is better than recursion because we are using a while loop, so we are not adding anything to the stack. It's like
Yep. Yeah. Uh, things are
yeah,
iterative
iterative.
will always be faster. But
Yeah.
yeah, that's basically it. Hopefully it's not too complicated. Maybe you can look back at the whiteboarding and it'll make more sense with the code. But yeah, that's basically it. So I'm stopping the recording.